I am Anil Kumar. Welcome to my series on calculus. We have had two lessons on limits, and based on these two lessons, here we have examination style test paper. I'd like you to go through these questions, understand the concepts, answer them. I'll be providing you the solution in the next video. Now, the questions are based on finding limits. We'll have question beginning with finding limits from a graph. Then we'll use a piecewise function and see how to find limit using a piecewise function. We'll have number of questions based on how to evaluate limits when algebraic expressions are given to us. Now some of these functions could be very complicated. Then we'll relate when the function's limit is given to us and then how do we work with them. We'll have questions based on absolute function. We need to sketch the graph when the limits is given to us, and we need to find a quadratic equation when conditions of the limits are given to us. So let's begin with the test paper. The very first question here is question number 1. Evaluate limit of function f of x from the graph. I'd like you to pause the video at this stage, have a close look at the graph given to you, and then answer these questions, the 6 of them. You need to find limit of f of x when x approaches minus 3, right? So that is the point minus 3. You can notice a hole in this particular graph. B, limit of the function f of x when x approaches minus 1. So minus 1 is this point, which you can see here on the graph. C, limit of the function f of x when x approaches 2 from the left side. That minus is approaching 2 from the left side. And then we have limit of this function when x approaches 2 from the right side. E, limit of the function when x approaches minus infinity, that is this end. And f is limit of the function when x approaches plus infinity, the other end. Now, based on this graph, we have the second question, which is write domain and range of the given function. Clear? So take your time to answer this question and post your answers. Here is the second question. Question number 3. We had 2 there. The second one was domain and range of the given graph. Question 3 is, given f of x is equal to x plus 1 whole square when x is less than minus 1. It is equal to x when x is in between minus 1 and 1, both included. It's equals to 2x minus x squared for x greater than 1. You need to determine following if possible. Sometimes the limit may not exist, right? A, limit of the function f of x at x approaches 2. B, limit of f of x when x approaches minus 1. C, limit of f of x when x approaches minus 1 from the right side. D, limit of f of x when x approaches minus 1. E, limit of f of x when x approaches 1. And the domain of the given function. Again, pause the video, answer the question, and then look into my citations. Question number 4, 5, 6, 7, 8, and 9 are based on evaluating limits. So we have a variety of questions here. First few are knowledge based and then the difficulty level increases. So have a good look at it. You might need to solve them in different pages, one after the other. Question number 4 here is to find limit when x approaches 8 for square root of 12x plus square root of 2x. Question 5. Limit x approaches 125 for 125 minus x over cube root of x minus 5. Question number 6. Limit of tan x minus sin x over sin cube x when x approaches 0. Question number 7. Limit 2x minus 3 divided by square root of 9x squared plus 5 when x is approaching minus infinity. Question number 8. Limit x squared plus absolute value of x minus 1 divided by absolute value of x minus 1 when limit of the function approaches x approaches 1. And the last question here is, you need to find limit of square root of 3x minus 1 divided by square root of 5x plus 1 plus cube root of 2x plus 1 limit when x approaches infinitely large value. So pause the video, copy these questions, solve them, write down your answers, and then look into my suggestions. So I'll be providing the suggestions in the second part of the video. Next question here is, question number 10. Now these questions are slightly different. We'll actually work with the function and the limits. Question number 10 is, given that the limit of f of x plus g of x when x approaches 0 exists, write function f of x and g of x such that the limit of f of x when x approaches 0 and the limit of g of x when x approaches 0 do not exist. So these are communication based questions. I'd like you to justify your answer. That will give you full marks. Question number 11 is, if limit of f of x is equals to 2 when x approaches 3, find the limit of f of x whole cube minus x squared over f of x minus 5 when x approaches 3. Question number 12. Sketch a graph of a function with following properties. Limit of f of x is equal to 3 when x approaches minus 2 from the left side. Limit of f of x is equal to 1 when x approaches minus 2 from the right side. And f of minus 2 is equal to 2. Here we have question number 13, 14, and 15. Now these are the last 3 questions of our test. You can always pause the video, copy these questions. Question number 13 is again function based, and it's a communication thinking question. If the limit of f of x over x where x approaches 0 is 1 and g of 0 is not equal to 0, then evaluate each limit. A, limit of f of x when x approaches 0, and B is limit of f of x over g of x when x approaches 0. Question number 14. Show that the limit of absolute value of x minus 1 times x plus 2 divided by x minus 1 when x approaches 1 does not exist. Sketch the graph and explain the discontinuity at x equals to 1. The last question here is, determine the value of a, b, and c for the function f of x equals to ax squared plus bx plus c, where a is not equal to 0, that satisfies the conditions f of 0 is 0, limit of f of x is 3 when x approaches minus 1, and the limit of f of x is 6 when x approaches 2. Perfect. So these are the 15 questions for you. Let's again go through them. So here's a second look at these questions. Well, the question given here on the top is one of the most difficult questions. It's a challenge and a bonus question in this particular video. Now the first one is, you have to read the limits from the graph itself, so that should not be very difficult, and then write domain and range. You have to notice the graph very carefully to write down the domain and range correctly. Then we have one-side limit questions based on a piecewise function to understand the concepts of piecewise function. And these are knowledge and some of them are thinking based questions to find the limit using the strategies which we learn. Most of the strategies were to factor, to rationalize, to change the variable, and then find the limit if the substitution method doesn't work. And then this is slightly different from what we had been talking about, but I thought let me take this opportunity to teach you something extra while we are taking the examination. I'll provide the solution and explanation of these questions later. So here we are given the limit of a function and then we want to know what the function looks like. So this has been extended a bit further, and then we have added three more questions which are also extended questions on the limits concepts. So we need to again work with the given limits of the functions and find the limits of new functions which are a part of the function or could be formed by composition of the function. Then we need to evaluate the, the function itself, and in the last question, we need to find the function when we are already given the limit of the function. Perfect. I hope you find this interesting and useful. So take your time. Calculator is not required in solving these questions, and post your questions at the earliest. We are going to discuss the solutions in the next video. Thank you for your time and all the best. I'm Anil Kumar. Welcome to my series on limits. Here is exam review on this particular unit. I hope you find these questions interesting and useful. We have already shared with you the questions, and in this part of the video, I'm going to answer them one by one, providing some explanation. For detailed explanation of similar questions, I'll recommend you to watch some of my videos. A playlist is there based on limits. There are many videos in this playlist. You can always watch them and understand the concept totally. So, most of the questions are testing your knowledge on limits from the graph, limits from piecewise functions, how to evaluate limits for different composition of functions, and then we need to relate limits when of the functions given to us. Questions are based on absolute function also, which should be treated as a piecewise function. Then we might have to sketch a function when the limits are given to us, and we might have to find equation of a polynomial. In this case, we have taken a quadratic function when the limit is given to us. So let's begin with the very first question and see how to answer this. So in question number 1, we are given a graph and we need to evaluate the limit of the function f of x from the graph. So the first one here is limit of f of x as x approaches minus 3. So when you're looking at minus 3, which is this particular point, you do notice a hole. However, even if there is a hole, the limit exists. The idea of limit is that what is the value the function is approaching when you are approaching that point from both the sides, that is left and right. So when you approach from both the sides, you approach this value of 1. So from both the sides, left side and the right side, the value approached is 1, and therefore the limit of this function is 1, correct? For b also, no, so b is for minus 1. So when you are approaching minus 1 from left side, what is the limit? And from the right side, what is the limit? Okay. So question B is find limit of f of x when x approaches minus 1. So minus 1 is this particular point. Now here you notice that from the left side you cannot approach. From the right side you are approaching a value of 3. So it does not exist. Since this value cannot be approached from the left side, you should be in a position to approach from both the sides. C. Limit of f of x when you approach 2 from the left side. So we are approaching 2 from the left side. So we are actually on this part of the curve. So when you are on this part of the curve, you approach the value 0. And therefore, the answer in this case is 0. limit of the function when you are approaching 2 from the right side. So from the right side, you can clearly see that you approach this value, which is 1, correct? So the answer for that one is 1. Next question is, for this function, limit when x approaches minus infinity. So you have to see, where is this graph going? It is approaching 0, correct? And therefore, this should be 0. Limit of the function when x approaches positive infinity, so that is the way it is going, and that value here is 3, and therefore this answer will be 3. Clear? Now let's look into domain and range of the function. Now since we have these two ends which are approaching infinity, so largely all the real numbers are included. So we can say that the domain is x belongs to real numbers. However, in between, we notice that some portion is not covered, especially this particular region. Do you understand? So it is not included in your domain. So that should be excluded, right? So where you can say x is not equal to some portion, right? So there are a couple of ways of writing this. So the easiest way will be, and here also we have a hole. Do you see that part? Right. So there are some discontinuities, and therefore we could write this like this. X is less than minus 3. So you have taken this portion, which is on the left side of minus 3. So that is included in the domain. And then union, you are going from minus 3 to minus 2. Both are not included. So minus 3 to minus 2, correct? And then union. After that, it starts from minus 1 to the right side. All other values are included. So we'll say x is greater than equal to minus 1, correct? So that becomes the domain of the given function. Now let's write down the range. So y values are equal to what? We have an absolute minimum in this case, correct? So y belongs to real numbers, but the values of y are above this value of minus 3. Since, all the points are covered, since this is going towards the positive infinity, we can say y is greater than equal to minus 3. Is that clear? So that is how you're going to answer the very first question. And the second one, based on the graph given to you. Now let's look at question number 3. Question number 3 is, given the function x plus 1 whole square where x is less than minus 1, f of x is x when x is between minus 1 and 1, and it is equal to 2x minus x squared for x greater than 1. We need to determine each one of the following. So when we say limit of f of x when x approaches 2, so let me rewrite this. So we want to find limit of f of x when x approaches 2. So in this case, when we are saying x approaches 2, definitely the value is greater than 1. So we are interested in this part of the function, correct? So therefore, we'll substitute 2 in the last equation. So we'll say this is equal to 2 times 2 minus 2 square. And that gives you the value 4, 2 times 2 and minus 2 square, 4 minus 4, and that gives you the value as 0. So that becomes the answer of part A. Is that clear to you? Now B. B will be limit of the function when x approaches minus 1. So we're seeing now the limit when x approaches minus 1 for the given function. So minus 1 will be where? Now in this particular case, you have to consider both, right? Because we have to find limit when approaching minus 1. You may not be there, but you are approaching from both the sides. So we'll say what is the left side limit and what is the right side limit, right? So in this particular case, you'll say limit when x approaches minus 1 from the left side is equal to what? Also, you'll find the limit when x approaches minus 1 from the right side, right? So both the values we need to figure out. So when you want to find the value approached from the left side, you will substitute minus 1 here. Minus 1 plus 1 in the first equation is 0. and therefore you get a value 0 here. And in the second one, if I substitute minus 1 on x, I get a value which is minus 1. That is also the value of the function. So in this case, it does not exist. Correct? So the value at minus 1 does not exist. Clearly. So that is how you have to answer this particular question. Now at this stage, you realize that it is better to sketch the graph and then answer the question. Do you understand? So you can continue doing this also. Perfect. But I think what you should do is you should sketch the graph. Now, once you have a graph, then it is easier and faster. But if you're trying to look at the equation itself and answering the question, it might take very long. So my suggestion is to sketch the graph and then answer. So now let's look into the solution, which should be the actual solution. Perfect. Now what you should do here is that you're given the function, you have the critical numbers which are defining your intervals. So on the left side of minus 1 is this particular portion, right? So on the left side we have a parabola which is x plus 1 whole squared. You can always sketch this by finding the values as we did while answering these two questions, correct? Then in between the values x, which means a straight line which goes through the center, and that is from minus 1 to 1, so those two ends are filled in. And then we have 2x minus x squared, where x is greater than 1, which is again a parabola which opens downwards as shown here. So once you have your graph, which has been sketched here for you, you can now answer these questions faster. That's the whole idea, right? So the concept is, in a test paper, it is better to sketch the graph and then answer. One, because you're looking at the graph, you are very sure about your answers, correct? So the very first one was limit of f of x when x approaches 2. Now, when you're approaching 2, you are there at this value, which is 0. So the answer is 2. It is continuous. Oh, sorry, it is 0. So when you're approaching 2, you approach y value of 0. Minus 1. So minus 1 is right there and it does not exist since you see there is a jump discontinuity, right? So it does not exist. C. When you are approaching minus 1 from the right side. Minus 1 from the right side, you are approaching minus 1. D. F of x when x approaches minus 1. Now at minus 1, it does not exist. So actually, I should have written different questions, slightly error here. So let me make this minus 1 from the left side. Correct? That is what I expected. From the left side, you are approaching a value which is 0. And for minus 1, it does not exist. Is that clear to you? So make this correction. Now, next one is limit of f of x when x approaches 1. You approach this particular point, it is continuous, and the value is 1. What is the domain of this particular function? So clearly you see that domain includes all the points. So x belongs to real numbers is the domain. Correct? So this whole, we have a filled in point here. So I hope that helps and you understand the strategy of how to solve such questions. Now, we have set of questions to answer. How do we answer these questions? So in this case, the very first one, you should substitute, right? So you should substitute and find the answer. So that should not be difficult. But if you start doing rationalization, you will spend a lot of time and which will not be worthwhile. So clearly, substitution is the first thing. But if you perform substitution, this is 0 over 0 form. So in this particular case, you could do rationalization, you could change of variable. So I'll suggest do change of variable. Now here, in trigonometric expression, you should simplify. Once you simplify, you'll actually get the answer very easily. Now in the next question, we are approaching infinity. So the limit of this function you need to find when x is approaching infinitely large value. Now whenever it comes to these types of question, remember one thing, that is square root of x squared is equal to what? It is equal to absolute value of x. That is very important. And now let me rewrite this. We're saying square root of x squared is equal to absolute value of x. And what is absolute value of x equal to? Absolute value of x is minus of x when x is less than 0, and absolute value of x is positive when x is greater than 0. Now you could take, because it is a continuous function, equal to sign either. We normally associate with the positive side. Okay, so that is kind of important to answer this particular question. Now the second one, which is question number 8 for you, again involves absolute function. Right? So most of the time, when you have an absolute function, you have to always write this in that particular form. And once you have written, you have to find one side limits. And then get your answer. The last question here is a bonus question. Now, we know that square root of x squared is equal to absolute value of x. But when it comes to cube root type of things, it becomes kind of difficult. So the hint I will provide here is kind of like this. We have cube root of 2x plus 1. We could think about squaring the inside part. Let me use a different ink. We can think about squaring this part and then square rooting. So it becomes the same thing. You get my point. So what you could do is you could write this as sixth root of 2x plus 1 whole square. And that is the key to solve this particular question. Once you do that, then you can use this concept of square root of x squared equals to absolute value of x and get your answer. Correct? So that's the whole idea. Now let me share with you short solutions of these questions, right? Question number 4. Here, in question number 4, you just substitute the value. So we need to find limit when x approaches 8. So substitute the value 8. Once you do that, you get 100 within the square root and the answer is 10. The next one here, you could do a couple of things. One, we could do substitution, which is, change of variable. So substitute the variable cube root of x with u. So change your variable from cube root of x to u. So in that case, u cube is x. So x is u cube. Now as x approaches 125, u approaches 5. So that is how you can change your variable from x to u, correct? Once you do that, you can always factor using difference of cubes, and then you get your answer as shown here. Perfect. So that is how you're going to solve this particular question. Let's look into the solution of the trigonometric function given to us. We need to find the limit of tan x minus sin x over sin cube x when x approaches 0. Now in this particular case, write tan x as sine over cos, as you do with trigonometric questions, right? Simplify your expression. Take common denominator, right, and then try to simplify. The whole expression, this is 3 layers of fractions. I kind of split and write like this. It's simpler and easy to understand. Now we have a term 1 minus cos x in the numerator, and we have a term 1 minus cos square x, which could be split into 1 plus cos x times 1 minus cos x, correct? Which I have done at this stage. That is one part. The second part to this is that we took actually sin x common, and therefore at this stage we could actually cancel sin x with sin x. So we simplified first one part of it and then the other part of it, and then we simplified this. And therefore we came up with an expression which had only cosine x. Now for limit x approaches 0, cos of 0 is 1, right? So you know cos of 0 equals to 1. So therefore you substitute these values here and you get your answer, which is half. Is that clear to you? So this is basically based on your skills to simplify the trigonometric expressions. Question number 7 and 8 solutions are provided in this particular page. Now we need to find a limit of 2x minus 3 divided by square root of 9x squared plus 5. Now remember what we had been talking about, which is square root of x squared is equal to absolute value of x, and this is equal to minus of x when x approaches, the other side, from 0, and it's plus of x when x is greater than 0. We take positive value on the right side. Of course, when it is in the denominator, we have to take care of the domain of the function. Perfect. Now, in this particular case, the idea is we can factor out x. Do you see how we are trying to simplify? So, in the numerator, factor x. So, we'll write here factor x, right? Or absolute value of x, as the case may be. So we did this factoring by dividing, and you know this portion here will approach to 0, right? So this portion is approaching to 0 for x approaching positive or negative infinity. So this is the basic concept. So as soon as you divide by x, the other term becomes 0. So in the numerator we have 2x. Now in the denominator, when we took x squared outside, we are left with 9 plus 5 over x squared. Since x is approaching minus infinity, the term 5 over x squared is approaching 0. So we replace that by 0 and wrote this as x squared times 9. Now absolute value of x is for x squared and square root of 9 is 3. And so we get our expression. Since we are approaching minus infinity, see that, since we are approaching minus infinity, we get this sign which is negative. Perfect, because that is the reason. Is that clear to you? Now this is a very, very critical part. So that is the path, because this was minus infinity, we got this sign. Now many times, even at this stage, you may do a mistake of not including the sign negative, then the whole thing will be wrong. The next question here is again with respect to absolute functions, which is to be treated as a piecewise function. So you need to write this absolute value of x minus 1 as a piecewise function. So absolute value of x minus 1 is basically equal to negative of x minus 1 when x is less than which value? Tell me. And is positive value of x minus 1 when x is greater than what value? The value which makes this 0, which is 1. Do you see that? So you have to split this between left side of 1 and right side of 1. And therefore, it has been solved in two ways. Two parts. One is when x is approaching 1 from the left side, and this is the right side. Do you see that? So this is left side limit, and this is the right side limit. So when you replace it and simplify, you get the answer, which is minus 1. And from the other side, it is 3. And you know, minus 1 is not equal to 3. So both the limits are not equal, and therefore, the answer is limit does not exist. Perfect. So that is how you have to explain your answer and then write it down. Question number 9 is one of the most difficult questions which you'll find in this set of videos or in this topic. Now, in this particular case, what makes it very difficult is the part where we have cube root of 2x plus 1. The other things are kind of clear since we have done many questions based on that. So let me talk about the other things first, and that is these things. So you need to factor out x as we did, and once you do that, you have to see that x is approaching infinitely large, so these values will actually approach 0. So you're left with 3 and 5. So that is how you get these two values. Is that clear to you? Now, let us look into the function, which is cube root of 2x plus 1. You could actually square the inside part. So if I do this 2x plus 1, if I kind of square it and then square root, that means sixth root. It is one of the same thing. 6 divided by 2 is 3, correct? So third cube root and sixth root of square, correct? They are the same thing. But it helps to simplify and answer the question. We could now expand this. So we get 2x whole square plus 2 times, which is expanding, plus 1 square, which is actually equal to sixth root of 4x square plus 4x plus 1. So that is what it is. So what you see here in the solution is that we kind of changed it to the sixth root after squaring the inside term. And then we expanded as shown here. Perfect. So we have 4x squared plus 4x plus 1. And now we want a term which is kind of square root of x squared. So what I did was we factored out x cubed. So when you factor out x cubed, we get 4 over x squared, 4 over 1 over x cubed. Now in this case, since the limit is approaching infinitely large value, what happens to these values? All of them approach to 0 actually speaking. But what we did was, we first worked with this, which is, we're trying to say what is this part, which is, let me write down here, 6th root of x cubed. Now 6th root of x cubed is like x to the power of 3 over 6, which is x to the power of, you understand? So you could also write this as square root of x squared, right? Because this is like square root of x squared, right? So x to the power of half, square root you could write here, right? So you could write this as square root. In this case, we are interested in square root x since we have square root x in the numerator also. So basically, it reduces to square root x. Let me add one more step here. So what you get here is x to the power of half, which is square root of x. This is better. Okay. So this term is actually equal to square root of x. Since it is square root of x, we can take it common, right? So then the square root of x terms are in 3 places. So they get cancelled. Do you see this portion? So that's what we did. After cancelling this, what remains with us is square root of 3. Okay. Uh, this this 6 is okay. So there is no space here, so that is why this step is creating confusion. So we factored out square root of x as I'm showing here. Is that clear to you? So we factored out square root of x. Now square root of x is common. We can take this as a common factor and cancel. So now we have in a position to cancel this since it is a common factor. So we have square root of 3, square root of 5, and within the 6th root, all this. Correct? Now, when x approaches infinitely large value, we are dividing by a very large value, so the expression here will be 0. And what we are left with is the answer, which is square root of 3 divided by 5. Perfect. So I'd like you to go through this, try to do it yourself, and take this as a hint for your solution. The last 3 questions here are question number 10. Given that the limit of this particular function f of x plus g of x when x approaches 0 exists, write functions f of x and g of x such that the limit of f of x when x approaches 0 and g of x when x approaches 0 do not exist. So what could you do? Well, there is a very simple solution to this. So let me give you the solution and then we'll discuss. How about having f of x as 1 over x and g of x as minus 1 over x? Now, we know that these two limits do not exist as x approaches 0, right? Since we want that this function and this function do not exist. So the limits do not exist for these functions. We have a vertical asymptote at x equals to 0. And therefore, they do not exist. But when you add them up, you get 0, right? So the limit exists. When you add them up, when you make it f of x plus g of x, it is 0, right? And the limit exists. A constant 0 and the limit is 0. Perfect. So in this particular case, when you add, the limit is 0 and that is your answer. Perfect. The next one here is you need to find the limit of this particular function, and what are you given? You are given that the limit of the function f of x is equal to 2 when x is equal to 3. Find the limit of f of x whole cube minus x squared over f of x minus 5. Now to do this question, what should you do? Use the properties of limits. So this is basically based on properties of limits. So you can substitute the value. So we need to find the limit of this particular function when f of x limit is given to us, right? So this we have to cube and then we have to write x squared divided by f of x minus 5, correct? Now we know the limit of f of x when x approaches 3 is 2. So we'll replace this by 2. So we get 2 cube here and x is approaching 3, correct? So we'll replace x with 3. So we get 3 square here divided by f of x is 2 minus 5. So this is 8 minus 9 over 2 minus 5 is minus 3. And so we have minus 1 over minus 3 or 1 over 3 as our answer. So the answer here is 1 over 3. Correct? Question number 12 is sketch a graph of the function with following properties. So it says that the limit of the function is 3 when x approaches minus 2. So we're looking at a point which is minus 2, right? So we are looking somewhere here at minus 2. And when you are approaching from the left side, this is from the left side, what do you approach? You approach a value 3. So from the left side, we are approaching a value 3. Do you see that? So this value is 3 for us. When you approach minus 2, from the right side, you are approaching a value of 1. So let's say this is 1, right? So that is how you're approaching. This is 1. And the value of the function at minus 2 is 2. So the value is like this to make a point here which should be included, right? So that is how, so this point here is 2. Does make sense to you? So that is how you could actually get your solution. Well, there could be many different questions based or solutions for this. For example, you could also sketch like this. So let me do another sketch here. So basically, we are looking for, let's say, let me draw a graph here. Okay, so we have these values. We are approaching this particular value, which is 1 for us, correct? So we could approach like this. We are approaching the other value. Sorry, that was at minus 2. Sorry, I'll redo this. I made it at 0. Okay, so let me redo the first one first. And I realize that we are working on the top. So let me move and make more room here. So we have the scale. Let's say that's our graph paper, okay? And this is the value for minus 2. Okay, now we'll again sketch this. So when you are approaching from the left side, and that is minus 2 for you, right? So from the left side, you're approaching a value, which is 3. So that is your value approaching. We could go like this. Is that clear to you? Now, when you're approaching from the right side, you're approaching a value. So this is 3 for you. And that is 1 for you. So you're approaching 1, so it could be kind of like this. Is that clear? And f of minus 2 is 2, so that is a whole here, not there. So that is how you're going to sketch the particular graph. Is that clear? So this is 2 for you. So that is how you should be doing it. Perfect. So that becomes the solution. And as you can see, there could be many solutions. So all these points, holes and the point of the function, should be at x equals to minus 2. Is that clear? Okay. Now that brings us to the last, almost at the end of our question. Now let's look into the last questions, which are question number 13, 14, and 15. So the question number 13 is, if f of x over x is equal to 0 when x approaches 0 and g of 0 is not equal to 0, then evaluate each one of these functions. So we need to evaluate the function f of x limit when x approaches 0. Now in this particular case, we are given that the limit of this function exists and it is equal to 1 when x approaches 0. What does that mean? So clearly, it means that the limit exists. That means there is a common factor. So this means there is a common factor. X in numerator and denominator, right? Clear? Since there is a common factor, I could always write f of x as x times another function. Do you see that part? Since there is a common factor, we could write this as x times another factor. Now, since x is there, x times hx, right? So limit when x approaches 0 will be 0 times h of x, which is 0. So the limit of the function f of x is 0. So that is how you get your answer. Is that clear to you? So that is how we are going to answer this particular question. So we know this limit is actually equal to 0. Correct? Now we need to find the limit of the other function. We know this could be written as limit when x approaches 0 for f of x divided by limit when x approaches 0 for g of x. Correct? We know the top limit is 0 and we know that this is not 0, right? So this is not 0. Clear? So 0 divided by any number will lead to 0 and therefore the limit of this function is 0. But you need to justify whatever I have said here and provide an explanation. However, the solution is given to you. Correct? That is how you are going to answer this particular question. Now let's look into the solution of question number 14. Question number 14 was, show that the limit of this function, absolute value of x minus 1 times x plus 2 divided by x minus 1, where x approaches 1 does not exist. So in this particular case, you have to write the absolute function as a piecewise function, correct? And then rewrite your equation with two sides, two pieces, one from the left and the other from the right. So the left side limit, substitute absolute value of x minus 1 with minus of x minus 1. And for the right side, it will be plus of x minus 1. And when you solve this, you get minus 3 and plus 3 as shown here. Correct? So those are the values. Now since these values are different, right, minus 3 is not equal to plus 3. Therefore, we have that the limit does not exist, and that is how you can explain that the limit does not exist at 1. And what you notice here on the graph itself is there is a jump discontinuity, right? So this is what we call jump discontinuity. Clear? So as you are approaching from the left side to minus 1, you are approaching a value which is minus 3. On the right side, you are approaching plus 3. Correct? So it kind of jumps. And there's a discontinuity. And that is how it should be explained. Clear? Now let's take the last question, which is a very interesting question. Determine the values of a, b, and c for the function f of x equals to ax squared plus bx plus c, where a is not equal to 0. Otherwise, it will not be a quadratic function, right? That satisfies the condition. So three conditions are given to us. The first one is f of 0 is equal to 0. That really means that the point 0, 0 is on the curve, right? Let's call this point as a. The second condition given to us is that the limit x approaching minus 1 for the function f of x is 3. That means the point minus 1, 3 is also on the curve. Let's call this point as b. The third condition given to us is limit x approaches 2 for f of x is equal to 6. So the third point c on the curve is when x approaches 2, the value is c. So that is the point which is being approached. Now, since the function is continuous, right? Why did we write this? We have a polynomial, right? Continuous function, where the limit is equal to value. So that is kind of critical. It is continuous. Limit of the function as x approaches a is equal to the value of the function as x approaches a. So the idea here is limit when x approaches a for f of x is equals to f of a. Perfect. And so we get 3 points. Now with these 3 points, we get 3 different equations as shown here. So very first one, when you substitute 0 here, a and b, right, are being multiplied by 0, so they become 0, and we get the value of c, which is 0. Once c is 0, I'm not using c here because c is 0. I'm substituting the second point, so here we substitute the point a, which is 0, 0. And then we substitute point B, which is minus 1, 3. And then point C, which is 2, 6. And we got different equations. Now, once you have these three equations, we can actually solve. So you need to solve the equation which is, let me rewrite, a minus b equals to 3. Correct? That is one of the equations. The other one is this, which is 4a plus 2b is 6. So basically, we need to eliminate 2b. So let me multiply by 2. So we get 2a minus 2b equals to 6. Correct? So we have this equation. 2a minus 2b equals to 6, and 6 is also equal to 6a plus 2b. So if I add these two, correct, then what happens? 6 plus 6 is 12, and 2a plus 4 is 6a, right? So we get 6a equals to 12, or a is equal to 2, correct? So we get the value of a as 2, which is mentioned here. So solving these equations 2 and 3, you will get this particular answer. So when you get a equals to 2, you can substitute 2 here in the equation and find what b is. So b is equal to a minus 3. In this case, a is 2. So 2 minus 3 gives you minus 1. And so we get our answer. Is that clear to you? That is how you're going to solve this particular equation. I hope the steps are absolutely clear. Feel free to write your comment, share your views, and if you want, you can join my classes on understanding calculus. You can register on the website or also send me email on the given address. The email address is given here. You can always contact me. We can look into the best ways of teaching you calculus. Thanks for your time once again, and all the best.